Morning, welcome to Computer Aided Engineering Drawing. In this chapter, we'll be discussing about development of solid surfaces. So here, to want to develop the solid surface means we have to unclose the path of the required surface so that you'll be able to exactly develop the required surface. So learning development is important to go with any type of basic solids to get the final picture. So in the development of solids, what we do is the basic solids what all we saw the position of solids for that you are going to pass the section plane and you are going to see how it exactly looks by passing the section plane at different angles. So what is this section? The action of cutting it is called sectioning of a solid. So the plane what you pass for cutting it is known as the section plane. So the two cutting action means section planes are recommended. So section plane perpendicular to VP and inclined to HP. Section plane perpendicular to VP and inclined to VP. Like this, two types of section plane are going to pass as it is shown in the diagram. So why we need a section plane means for the basic solid we are going to pass the section plane and develop the surface which will be used for particular application. How do you develop the solid surface means assume a object which is hollow made up of a thin sheet, cut open it from one side and unfold the sheet completely. Then the shape of that unfolded sheet is called development of the lateral surfaces. So here the lateral surface is the surface which excluding the solid top and base. There are so many products of objects which are difficult to manufacture by conventional manufacturing process because of the shapes and sizes. So development gives a technique where it will be applied to the required shape, especially it is in the sheet metal industry. Development techniques, there's a vast range of such objects. An example, boiler shells and chimneys, pressure vessels, shovels, trays, box and cartoons, feeding hoppers, large pipe sections, body and parts of automotive ships, aeroplanes, and many more applications are there where we have to develop the surface so that by attaining the required shape that particular object will be useful. So here we'll be going ahead with some of the basic entities of the drawings, how to develop the surface. We'll be going in detail. So when you develop a cylinder, it has got the base diameter and height of the cylinder. So if you develop a rectangle, so if you unfold the cylinder surface, so it will be a rectangular face. What will be the overall length is pi into the diameter. If you take, that will be the development of the regular cylinder. If you take a prism, the number of rectangles which lies side by side is supposed to you're supposed to add to the one surface. So S is the given side. So if it's a prism means pentagonal prism is you need five rectangular faces with the required height so that you'll be able to get. So height is the overall length of the prism. S is the given side. So if it has got five faces, there will be five rectangles which will be lying side by side. If you take cone, if you unfold the cone, it will be the sector shape. So here the base circle radius is r, L is the slant height. If you want to find out the theta angular inclination of the cone is capital R divided by capital L into 360 degree. So here, like this, you are going to be able to develop the cone. If it is a pyramid, then you are supposed to find out the length of the slant edge, that is L, and the given side you are supposed to mark on the arc which you draw for the given length L. So L is the slant edge, S is the edge of the base. Like this, you will be able to develop the pyramid. If it's a tetrahedron, it will be 4 equilateral triangles, all sides having equal length. So base triangle it will be same. If you unfold the remaining 3 triangles, it will be opening at the side. So like this, you'll be able to do development of this lateral surface of the different solids. So we'll keep on applying to the basic solids by passing the section plane and you develop the surface. So if you take cube, it has got a 6 squares. You can lie 4 squares at the side, 2 flaps at the corner you can open. Like this, it will be having 6 squares. So after passing the frustum for the given cone, so L1 is the length where the small part of the cone is removed, and capital L is the overall length. So here if you unfold the cone, you have to know the theta. Theta, as you know, capital L divided by capital capital R divided by capital L into 360. If you do, you'll be able to calculate. So by taking L1, if you draw the arc, you'll be able to get the curve. So if you join it, that will be the base circle. So if you develop the frustum of a square pyramid, so the L slant edge of the pyramid, if you draw the arc and if you connect with respect to the slant edges, and if you draw the arc, so the given side with respect to the connecting points, if you draw the straight line like this, you'll be able to get the frustum of the square pyramid.